Hello and welcome to the very first videos of four type of distribution, statistical distribution. Uh, the first one is going to pertain to the Z distribution, and that's based on normal distribution. And also we're going to be talking about T distribution in P proportional distribution, and also lately at the end we're going to talk about the chi-square. The very first thing that I wanted to keep in mind is to keep the five step that we have to follow in every state. Hypothesis testing. Sorry. First of all, we have to state the null hypothesis, which is what is known to be true to the researcher, or what is common believed, the situation that is innocent until proven guilty. The alternative is what's going to defy or go against the belief that is stated in the null hypothesis, the rejection of what is traditionally or normally is accepted as a common belief, that is the high H1, which is the alternative hypothesis. Also, after we determine the null hypothesis and the alternative hypothesis, we're going to move to choose the level of significance that is going to be based on alpha. It's a Greek letter to determine the significant, whether it's going to be 5% or point. Yeah, that also determined, let me go ahead and shift my thoughts here, determined by the confidence level. If it's 95%, it's going to be basically a alpha is 5. But also alpha is going to be looked at closely to determine whether it's two-tailed situation, that we have to divide it by 2. But there is something in Minitab I'm going to share with you that is going to calculate alpha, even we have two tails associated with it. Then we're going to find the critical values. Those are going to be looked up either in a table at the end of the book, or maybe we could also look it up in Google if you wish to do that. Also, we could look it up in using Minitab. After we determine the value that is going to initiate the critical values, which is going to really start the rejection region, that is going to be based on the value that we're going to look it up. That's something we look up. We're going to go through the calculation of the z-score if it is a normal distribution based on the distribution, test statistics, any of those four that I mentioned, the t, the z, the p, or the chi-square. Then we're going to draw the conclusion based on whether we accepted or rejected the null hypothesis. We normally don't use the word accept, but we're going to use it in order to make it easier for us to come to the conclusion very quickly. I'm going to use this gentleman. I really like his approach and his simplicity to come up with four of those different tests. This is his URL, or basically the address for his videos if you want to watch them. But because we're going to really use a manual calculation, or also we're going to use Minitab in his videos, there is no mention to Minitab, so you need to really watch everything that we're going to do here. Let's take a look at the first problem, and we're going to use Minitab, and we're going to use Excel as well if we need it as a calculator. Any calculator will do. So carefully, we're going to read the problem, and we're going to see what type of distribution it is, and we're going to also make sure that whether we're dealing with a large sample or small samples, that also is going to help us to determine the type of the distribution. Also, if there is one point that I have to bring, if the confidence level is not stated, usually we assume it's 95%, resulting into a 5% of alpha. So the average IQ for the adult population is 100 with a standard deviation of 15. So it was stated repeatedly over and over and over that the IQ, the average IQ for adult population, is 100 with a standard deviation 15, meaning within one standard deviation it goes 15 points. So within one standard deviation we have to the right 115, to the left 100 minus 15 is 85. So now we're going to take a very close look at the wording, because we have to determine whether it's what type of curve we're going to end up with? Is it going to be two tails or is it going to be one tail? A researcher believes this value has changed. It didn't say greater than, it didn't say less than, it's changed. It has changed, it's being not anymore equal to the normal one or to the accepted one or to the traditional one or to the agreed upon one, which is the IQ of 100. So the researcher decided to test the IQ of 75 random adults. The 75, that's a big number, a greater than 30 or greater than or equal to 30. And since we know the standard deviation for the population as a whole, for sure, this is going to be a normal distribution, and we're going to do the traditional z-score for testing the value later. So the average IQ of the sample is 105. After they studied those 75 score, they found the average IQ is 105. There is evidence to suggest the average IQ has changed. So if we rejected the null hypothesis, we will say there is an evidence to suggest the average IQ has changed. If there is no, we could not reject the null hypothesis, then nothing changed. If we stay with what was known to be, what we stay with what would be the whole world agreed to agree about the IQ as 100, the value for a normal individual 100. So let's go ahead and take a look at those steps as we will see here. And we're going to go ahead and use Microsoft Word quickly in order to show you how to do the whole thing. So I'm going to go ahead, first of all, state the null hypothesis and the alternative hypothesis. Since the normal, the problem was stating that the null hypothesis is mu is going to be 100. I use the mu here. If you don't see it in Word, actually I got it from the symbol here by looking it up. And you could search it actually by saying here mu, and it will give you the same thing for the inequality. Then, because it didn't say greater than or less than, and it says has changed, then it's going to alternative hypothesis, which is going to be H1 or HA is going to not equal to the 100. Now, I'm going to erase all these and take you through the second step. Second step, we're going to go ahead and determine the alpha. And nothing been mentioned about the confidence interval, or sorry, the confidence level. So I'm going to assume it's 95%, 95% resulting into alpha of 5%. So resulting into alpha. I'm going to go ahead and use that symbol here for alpha as 0.05. But we have two tails. And we're going to go ahead and get alpha divided by 2. So alpha divided by 2 is going to give me basically this is two tails is going to be 0 to 5. So this is my alpha. Now we're going to go ahead and look for the critical value, which means what is the z value at the 95% confidence interval or alpha 0.5 with two tails, which we divide that into two side of it. So this is I could look it up. I could go actually look it up in Google if you wish, and you will see me. I could go ahead and shift that to Google directly, and as you will see here, I could go to Google and I could look it up here. See, I could say alpha at 95% confidence interval, okay, and z-score. Could type this. In no time, you'll be able to find this. Basically, here we go. Some of that. It's a little bit harder to find here, but I could go ahead and find another one, finding the z alpha over 2. And this is a little bit more complicated. Here it is, actually. It's a little bit smaller, but you notice alpha with 95% over 2, it's going to be over to 1.960. This one way of doing it, it's a little bit awkward over the video to show you, but I'm going to go ahead and use main tab in this case. So I'm going to go to the graphic quickly, and I'm going to go probability distribution, and we're going to go ahead and do this. It's a normal distribution leave the mean as 0, the standard deviation as 1, and go to the shaded area and leave it as the probability with both tail. Give me your attention here because we haven't done this before. And leave it at 0.05 for alpha because we are defining it between two tails. In no time we'll find the z-score, which is going to tell me what is basically uh, the start of the critical region, which is 1.960 and minus 1.960. So as a result, you need to notice that we're going to start at 1.95. Here we go. I'm going to go ahead and copy this, copy the whole thing. Okay, copy the graph. Go to Microsoft Word and paste it here for me. See? So that will remind me. Just use go ahead and squeeze it. No big deal. And this is my critical region at didn't copy the 90. 1 second here. I'm going to go back to this one here. And I need to copy everything. Need to copy everything. All right. You see here, copy graph. And I wanted to copy it along with the z-score, which is, hopefully this will do it. No, it didn't do it. But again, I could take that from the z-score, it's going to be either 1.96 or z is going to be minus, because we have to region minus 1.96. And so we have here 4. And as a result, we're going to go ahead and calculate that. We want to see if the calculated z is going to be, this is the beginning of the rejection region from the left, and this is the beginning of the critical region from the right. And if we ended up calculating z, and if z is greater than or less than 1.96 or less than 1 minus 1.96, we should reject the null hypothesis. Z, as you know, it's the x bar, which is in this case is 105 minus the 100, and both of them are going to be actually surrounded with two parentheses, divided by the 15, which is the divided by 15, which is the standard deviation, which is also divided by the square root of the 75 for the end. But here we have to do it this way. We have to do it this way here. All right, so let's go ahead and take that to Excel and see what we're going to come up with. We're going to take that to Excel and see what we're going to come up with. Here is Excel, and we should get this value, by the way, unless I did something wrong. In this case, here we go. 1, 2, 3, 4, 5, and here we go. And okay, square. And say here 105 minus 100, that's the top, so it's going to be 5, and then it's going to do the 15 divided by the square root of 75, that's in, and that's going to give me 1.5. So I could go ahead and divide this by this, and we're going to get 2.88. I'm simplifying the calculation, so, and this is going to be actually 2.89, which is basically, as you will see from the word here, that the calculated z is 2.89, and therefore this is much greater than the 1.96. Therefore we're going to, again, just put it that way, 5, reject that null hypothesis, And this way we could go ahead and get the statement here, by stating that, let's take a look at the problem, and we could go ahead and grab that wording here. Yes, there is enough evidence to suggest the average IQ has changed, because it's not anymore what used to be normally believe that it's equal to 100, it does actually